Connecting telecom equipment to a power source involves several key steps. Ensuring safety and compliance with electrical codes are paramount. Before commencing any work, verification of safety measures is absolutely essential. Ensure the equipment is turned off and all power is disconnected before beginning any work. This minimizes the risk of electrical shock or damage to the equipment. The initial connection involves a portable cord. Connect the portable cord with the male cord cap to one of the 15-amp receptacles on the APC unit. This provides a flexible power source from the APC battery backup. Following the power source connection, the next step involves installing a junction box. Install the 4-inch square junction box in a convenient location near the APC unit. This box serves as a central point for wiring connections and provides protection for the electrical connections. With the junction box in place, the next phase involves running conduit and wire. Run conduit and THHN wire from the junction box to the other equipment room. Conduit protects the wires from physical damage, while THHN wire is commonly used for its heat resistance and insulation properties. Once the conduit and wiring are in place, the next step is installing a receptacle. Install a receptacle in the junction box in the other equipment room. This receptacle will serve as the power outlet for the telecom equipment. After installing the receptacle, the connection of the telecom equipment can proceed. Connect the telephone switching equipment or WAN network equipment to the receptacle. This provides the necessary power for the equipment to operate. With the equipment connected, it is crucial to secure all connections. Tighten all electrical connections securely and ensure all wires are properly dressed and supported. This prevents loose connections and ensures reliable power delivery. Finally, the last step is restoring power. Reconnect power to the APC unit and equipment. Before fully completing the installation, there are several important considerations. Firstly, ensure the receptacle installed in the other equipment room is rated for the current requirements of the equipment. This prevents overloading the circuit and ensures safe operation. Secondly, use proper wire gauge based on the current requirements and distance between the APC unit and the equipment. This minimizes voltage drop and ensures sufficient power delivery. Thirdly, label the receptacles and circuit breakers appropriately for identification. This simplifies troubleshooting and maintenance in the future. Fourthly, test the circuit to ensure proper operation after installation. This verifies that the wiring is correct and the equipment is receiving the necessary power. Lastly, always comply with all applicable electrical codes and regulations. This ensures the installation is safe and meets legal requirements. The materials involved include an APC unit with a 30-amp circuit to multiple 15-amp receptacles, a short portable cord with a male cord cap, a 4-inch square junction box, conduit and THHN wire, and a receptacle for the equipment. The procedure involves 7 major steps. Firstly, verify safety measures. Secondly, connect to the portable cord. Thirdly, install the junction box. Fourthly, run conduit and wire. Fifthly, install a receptacle. Sixthly, connect equipment. Seventhly, secure connections. Lastly, restore power. Several important considerations must be observed to ensure safety and compliance. These considerations include ensuring the receptacle is correctly rated, using the proper wire gauge, labeling components, and testing the circuit. The rooms where the equipment is installed are locked and accessed by maintenance personnel. When working with electrical systems, it's important to understand the concepts of voltage, amperage, and resistance. Voltage, measured in volts, is the electrical potential difference that drives the flow of current. Amperage, measured in amps, is the rate of flow of electrical charge. Resistance, measured in ohms, opposes the flow of current. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This relationship is fundamental to understanding how electrical circuits work. For example, if a circuit has a voltage of 120 volts and a resistance of 10 ohms, the current flowing through the circuit would be 12 amps. Understanding these concepts is crucial for selecting the right components and ensuring the safety of the electrical installation. Electrical codes, such as the National Electrical Code or NEC, provide detailed guidelines for safe electrical installations. These codes cover various aspects of electrical wiring, including wire sizing, conduit installation, and grounding requirements. For example, NEC Table 310.15b16 specifies the allowable ampacities of insulated conductors based on their size and temperature rating. It's important to consult the NEC and local electrical codes to ensure compliance with all applicable regulations. Wire gauge refers to the size of the wire, which affects its current carrying capacity. The American wire gauge, or AWG, is a standard system for denoting wire sizes. Smaller AWG numbers indicate larger wire sizes, which can carry more current. For example, a 12 AWG wire can typically carry 20 amps, while a 14 AWG wire can typically carry 15 amps. Selecting the appropriate wire gauge is crucial for preventing overheating and ensuring safe operation. Conduit is a protective tubing used to enclose electrical wiring. There are several types of conduit, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Each type of conduit has its own advantages and disadvantages depending on their application. For example, rigid metal conduit provides excellent physical protection but is more difficult to install than flexible metal conduit. Grounding is an essential safety measure that provides a path for fault current to flow back to the source. This helps to prevent electrical shock in the event of a fault. Grounding systems typically consist of a grounding electrode, such as a ground rod or water pipe, and a grounding conductor that connects the equipment to the grounding electrode. Proper grounding is crucial for ensuring the safety of electrical installations. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When the current exceeds the rated capacity of the device, it trips or blows, interrupting the flow of current. Circuit breakers are resettable, while fuses must be replaced after they blow. Selecting the appropriate overcurrent protection device is crucial for preventing damage to the equipment and ensuring safety. Electrical safety is of paramount importance when working with electrical systems. Always de-energize circuits before working on them, and use appropriate personal protective equipment such as gloves and safety glasses. Never work on electrical systems when you are tired or distracted. Following these safety precautions can help to prevent electrical shock and other injuries. Electrical connections must be made properly to ensure reliable power delivery. Use appropriate connectors and tools for making electrical connections and ensure that all connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to fires. Labeling electrical components is essential for easy identification and troubleshooting. Use permanent markers or labels to identify circuit breakers, receptacles, and other electrical components. This can save time and effort when performing maintenance or repairs. Testing electrical circuits is crucial for ensuring proper operation and safety. Use a multimeter or other testing equipment to verify voltage, current, and resistance. This can help to identify potential problems and prevent equipment damage. Regular maintenance is essential for ensuring the long-term reliability and safety of electrical systems. Inspect electrical components regularly for signs of wear or damage, and replace them as needed. This can help to prevent unexpected failures and ensure the continued safe operation of the equipment. In summary, wiring a dedicated circuit for telecom equipment involves careful planning, proper installation techniques, and adherence to electrical codes and regulations. By following these guidelines, you can ensure a safe and reliable power supply for your equipment. When dealing with electricity, always prioritize safety and consult with a qualified electrician if you have any doubts or concerns. Remember to de-energize the circuit before starting any work, and use appropriate safety equipment. Always double-check your connections and test the circuit after installation to ensure proper operation. Also ensure the proper amperage ratings are observed. If the rating on the receptacle is 15 amps, do not attempt to use a high amperage device on it. All electrical work should comply with the National Electrical Code as well as all local municipal codes.